Hey everyone, it's Steve here. I'm here to talk about the test pyramid and why it matters. Here we go. The test pyramid is a metaphor that describes a way to think about different kinds of automated tests. It provides a structured approach to testing, ensuring that different types of tests are used effectively to maintain software quality. It helps development teams create a balanced test suite by emphasizing the importance of having a variety of tests at different levels. This balance is crucial for catching different types of issues early in the development process. It's a visual representation of how many tests you should have at each level of software testing. The base of the pyramid is wide, representing a large number of unit tests, while the top is narrow, indicating fewer end-to-end tests. The pyramid shape illustrates the idea that you should have more low-level tests than high-level tests. This structure helps ensure that the majority of testing is done quickly and efficiently. This is because low-level tests, like unit tests, are generally faster and cheaper to run. They focus on individual components of the software, making it easier to identify and fix issues at an early stage. They are also easier to maintain. Since unit tests are small and isolated, they require less effort to update when changes are made to the codebase. High-level tests, like UI tests, are slower and more expensive to run. These tests simulate user interactions and validate the software's behavior from an end-user perspective. They are also more brittle, meaning they are more likely to break when the code changes. This brittleness can lead to increased maintenance efforts and longer debugging sessions. Using the test pyramid helps you build a robust test suite. By following this approach, you can ensure that your testing strategy is comprehensive and effective. It ensures that your code is well tested at all levels. This multi-layered testing approach helps catch issues at different stages, reducing the risk of critical bugs making it to production. This can help you find bugs early. Early detection of bugs is crucial for minimizing the cost and effort required to fix them. It also helps you prevent regressions. By continuously running tests at all levels, you can ensure that new changes do not introduce new issues, maintaining the overall stability and quality of the software. Unit tests are at the bottom of the test pyramid. They are the most fundamental layer in the testing hierarchy. They form the foundation of your testing strategy, providing a solid base upon which other tests are built. These tests focus on testing small, isolated units of code. By isolating each unit, we can ensure that individual components function as expected. These units are often individual functions or methods. Each function or method is tested independently to verify its correctness. The goal is to ensure that each unit of code works correctly in isolation. This isolation helps in identifying issues at the most granular level. Unit tests may be written by developers as they are writing the code. This practice is known as test-driven development, TDD, where tests are written before the actual code. They are small and fast, making them quick and easy to run. Because of their speed, they can be run frequently, providing continuous feedback. This allows developers to get immediate feedback on their code. Immediate feedback is crucial for maintaining code quality and catching errors early. They can catch bugs early in the development process. Early detection of bugs reduces the cost and effort required to fix them later. By having a strong suite of unit tests, you create a safety net for your code base. This safety net ensures that changes do not introduce new bugs. This makes it easier to refactor and improve code over time without fear of introducing breaking changes. Continuous refactoring and improvement are essential for maintaining a healthy code base. In summary, unit tests are a critical component of a robust testing strategy. They provide confidence and stability, enabling developers to innovate and improve their code continuously. As you move up the test pyramid, you encounter integration tests. These tests are designed to verify that different parts of your application work together correctly. This might involve testing interactions between different modules within your codebase, or testing how your application communicates with external services. Integration tests are typically more complex than unit tests. They require more setup. However, they are crucial for ensuring that the different parts of your application function harmoniously. They help catch integration issues that might not be apparent from unit tests alone. Service tests occupy a specific niche within the test pyramid. They focus on testing the functionality of specific services within your application. A service could be an API endpoint, a background job processor, or any other independent component that performs a specific function. Unlike integration tests, which focus on the interactions between components, service tests isolate and test individual services. They ensure that each service meets its specifications and handles requests and responses correctly. This helps identify issues related to data processing, business logic, or communication with other services. Section 5. Reaching the top, UI tests. At the top of the test pyramid, we find UI tests. These tests interact with your application through the user interface. They simulate user actions like clicking buttons, filling out forms, or navigating through different screens. Due to their nature, UI tests are the most time-consuming and brittle tests to write and maintain. They often rely on specific UI elements, which can change frequently during development. However, they are valuable for ensuring that the user experience is as intended and that the application behaves correctly from the user's perspective. Section 6. Pre-deployment testing, a separate category. This section delves into the various testing methodologies that are essential but often overlooked in the traditional test pyramid. Pre-deployment testing, including user acceptance testing, UAT, beta testing, performance testing, and security testing, falls outside the traditional test pyramid. These tests are designed to ensure that the software is not only functional, but also meets the end user's expectations and performs well under various conditions. These testing types are crucial for ensuring the overall quality and readiness of your software before deployment. They help in identifying any potential issues that could affect the user experience or the software's performance in a live environment. UAT involves real users testing the application in a real-world setting to ensure it meets their needs. This type of testing is vital because it provides insights into how the software will be used in everyday scenarios, highlighting any usability issues or missing features. Beta testing involves releasing the software to a limited group of users to gather feedback and identify any remaining issues. This phase is essential for catching bugs that may not have been discovered during earlier testing stages, and for understanding how the software performs in diverse environments. Performance testing assesses the application speed, responsiveness, and stability under different load conditions. It ensures that the software can handle high traffic and perform efficiently, which is critical for user satisfaction and retention. Security testing identifies vulnerabilities and weaknesses in the application that could be exploited by attackers. This type of testing is crucial for protecting sensitive data and maintaining the integrity of the software, especially in an era where cyber threats are increasingly sophisticated. Section 7. The importance of a balanced test pyramid. The key to a successful testing strategy lies in maintaining a balanced test pyramid. This means having a sufficient number of tests at each level of the pyramid, with a focus on unit tests as the foundation. Having too many high-level tests can lead to a slow and brittle test suite that is difficult to maintain. Conversely, relying solely on low-level tests might not uncover integration or user interface issues. By striking a balance, you can ensure that your code is thoroughly tested at all levels, giving you confidence in the quality and stability of your software. Section 8. Benefits of the test pyramid approach. Adhering to the test pyramid approach offers numerous benefits. Faster feedback loops, unit tests, being fast and isolated, provide rapid feedback to developers. Early bug detection. By catching bugs early in the development cycle, the cost of fixing them is reduced. Improved code quality. Writing tests forces developers to think about different edge cases and write more robust code. Easier maintenance. A well-tested code base is easier to refactor and maintain. Section 9. Conclusion. Building confidence through testing. The test pyramid provides a valuable framework for building a comprehensive and effective testing strategy. By focusing on unit tests as the foundation and gradually moving up to higher level tests, development teams can ensure that their software is thoroughly tested at all levels. This approach helps build confidence in the quality and stability of the software, reduces the risk of bugs, and facilitates the delivery of high-quality software that meets user expectations. Section 10. Implementing the test pyramid in your workflow. Now that we have explored the various layers of the test pyramid and their significance, let's talk about how you can implement this strategy in your own development workflow. Start by identifying the core functionalities of your application and write comprehensive unit tests to cover them. These tests should be fast and provide immediate feedback. Next, move on to integration tests to ensure that different modules of your application work harmoniously together. These tests should cover key integration points and critical workflows. For service tests, focus on verifying the interactions with external services and third-party APIs. Make sure these tests are reliable and handle potential failures gracefully. Finally, create a set of UI tests to validate the user interface and end-to-end user journeys. These tests should be maintained and updated regularly to reflect changes in the UI. By following this structured approach, you can create a robust testing strategy that enhances the quality and reliability of your software. Remember, the key to a successful test pyramid is balance and consistency. Thank you for watching. Don't forget to like, share, and subscribe to our channel for more insightful content on software development and testing strategies.